So today we have a 2007 Ford F150 King Ranch 4x4, and he's got a couple of complaints. Well, the door ajar light is on, but the low fuel gauge message comes up. The fuel gauge reads empty all the time, and the check engine light is on. I think the check engine light was a pre-existing condition before the fuel gauge problem, but the fuel gauge reads empty, and if the door ajar message wasn't on, it would show low fuel level as it does there. So first thing we're going to do is scan it and see if there's any codes in the fuel gauge for the fuel gauge that'll help us along here. So I've got the key on, engine off, and I'm going to do a network scan here. I've already ID'd the vehicle. I've worked on this before, and I think the last time it was in, we determined there was a problem with the intake manifold runner control, but we did not do anything at that time. We're going to see if that's the same fault code that's illuminating the check engine light now. 0754, and let's do a code scan and see what comes up. Key on, engine off. Well, this code scan will take several seconds, so I'll pick up. Well, it seems to be moving along pretty quick. Yeah, that was very quick. Cylinder 5 misfire detected. That's interesting. He never mentioned anything about a shake. Misfire detected on startup. Bank 2 catalyst efficiency below limit. Fuel level sensor performance. Fuel level sensor height input. High input. Intake runner control. So he's got a number of... This is why the fuel gauge isn't working, so we're going to have a look at how that circuit is designed. But these are new codes. They were not there before when we scanned this thing last time. Cylinder misfire. Wheel speed error. Spinning the tires might do that, but that could also be caused by a wheel speed sensor. Fuel sender circuit fault. Low battery voltage at module. Transfer case. Wonder if he's had a problem with the battery going dead and he's been boosting it or charging it. Well, number of issues. Let's have a look at this fuel gauge and how it's designed. So I've loaded the vehicle in Identifix, and I'm looking at the fuel gauge circuit. This is a flex fuel vehicle, so it has this option here, flex fuel. So the fuel pump module has a variable resistor in it, and then that goes to a fuel pump module, AC-DC converter, and from there it is sent to the instrument cluster, and I guess the instrument cluster then networks it to the PCM. I wonder what this fuel pump module does. I wonder if that has to do with alcohol content. I'm going to read this circuit in the circuit description. So here's a case on Identifix for that P0461-463 code. It says the fuel level sender resistance should be 15 ohms empty and 160 ohms with a full tank. So we could check that fairly quickly, I think, if we can get to the connector. Obviously, if it's out of that range, that's likely the cause of the problem. I don't recall if it had this B1201 in the instrument cluster. Let's go back and look in here. Yes, it does. B1201 in the instrument cluster. Okay, well, we'll put it up in the air and have a look at the wiring. So visually looking at it from underneath, the connector on the fuel pump module itself is nearly impossible to get to without dropping the tank. I'm going to see where this connector 431 is. Maybe that's accessible. 431. Looks like it's right on top of the tank. That's a pretty crappy diagram. And this doesn't move over. as near as I can tell, that's right on top of the fuel pump module itself. I wonder if that AC to DC converter that they're talking about is part of the fuel pump module. It certainly looks like it, because it says it's connector 4074 without flex fuel and 431 with flex fuel. So it doesn't look like there's any other spot we can check this. So I decided to have a look at this connector 431 face view, and that's not what I have on top of the tank. So it turns out this vehicle might be just a standard system, because it has this rectangular connector, this rectangular 4-pin connector on the top of the tank. Now in the schematic it shows connector 327, and it's located on the side of the outside of the frame rail, fairly accessible. So at that connector I should be able to test the fuel gauge by disconnecting and putting a variable resistor in here to make sure the fuel gauge is fine, and measure the resistance of the fuel pump module variable resistor, provided of course these wires are okay. Either way, if it tests out of range, then the tank's got to be dropped to qualify it from there. So I'm going to find connector 327. Let's see what it looks like. I think it's a fairly big connector. Yes, it's a big rectangular 20-pin connector. So here's where that connector lives, Ford. Just a little bit of sand and dirt. They got a plastic guard over it, which is broken. But this is the connector in question here. Well, we're going to clean all this dirt out of here and see how this connector cover comes off. Looks like there's a couple of clips here. And see if there's any compromised wires back there. So I don't see anything obviously wrong here. This upper connector, I think, is the one in question. Considerable amount of mud behind there, but nothing obvious. So we're going to double check to see that we're on the right connector by looking at the wire colors. Pins 1 and 11 are orange and gray-red. So this one is orange and gray-red. So that orange wire and gray-red wire is pin 1 and 11. And we're looking, damn Ford, they just put the circuit numbers on here. They don't put the explanation of what the circuits are. So we'll get the wiring diagram. So we're going for pins 10 and 19, which are yellow and white and black and orange. So turns out the black and orange is pin 10, looking at the connector here, and the yellow and white pin 19. So black and orange is there, and yellow white is here. And I just tugged on those wires to see if there was anything obviously wrong. And let's look up here and see. There's the yellow wire on that corner and the black orange wire on that corner. Well, we're going to put an ohmmeter across these two pins in this harness, and that should read the resistance of the sending unit. So I got the ohmmeter connected across pins 10 and 19. 10 is black and orange, 19 is yellow and white, and this is going to the fuel tank sending unit. I got the ohmmeter set up to read 400 ohms max, and it's reading over scale. I'll just try a higher resistance to see. Oh, I was on 400K. So it's over 4 million ohms. It should have been reading somewhere between 15 and 160 ohms. Now the question is that all that's wrong? So what we're going to do is we're going to hook up a variable resistor to the corresponding pins in here and dial up some range between 15 and 160 ohms and see if the gauge responds to that properly. Make sure that when we take the tank down and confirm this problem, possibly change the fuel level sender in the tank, it's going to fix it. So I got this variable resistor box set at 150 ohms. Make sure all these are off, the switch is in ohms. Got it connected across the female terminals using appropriate probes so that you don't compromise the terminals in there. And we're going to climb up in the cab and turn the key on and see what the fuel gauge reads at 150 ohms resistance. So dialed up to 150, it reads full. So I'm going to turn it down to roughly 75 theoretically. 70, 75, it should show about a half a tank. Now I turned the key off when I adjusted the sending unit resistance, because if you do it with the key on and turn the resistor down quickly, most of the time the fuel gauge will go into an anti-slosh mode, or it'll disregard the change because that's an unrealistic rate of change. But if you cycle the key off and then back on, around 70 ohms, I'm estimating, showing just under half a tank. So I'm pretty sure the gauge and the wiring from here down to that connector is fine, and the problem's either in the harness between that connector and the fuel pump, or in the sending unit itself. But to get at that connector on top of the tank, I got to remove the tank. So as you can see, I got this one resistor set at approximately 70 ohms, 75 ohms. And I said if you have the key on and you turn the resistor and change it quickly like that, the circuitry might determine that to be a faulty sending unit or a faulty circuit and then disregard the change. But if you cycle the key between adjusting the resistor, as long as you don't go out of range, it should be okay. So again, we're testing it at this connector going from here up to the dash, and it's fine with a simulator. So there's either a problem in this wiring harness to the tank, or it's in the tank. But get to the connector on top of the tank, you got to drop the fuel tank. Even taking the box off this thing is not going to work from what I can see. Can't see under here, but there's a rib right on top of the fuel pump and it's underneath the cab, so got to drop the tank. So those are the two wires, the black and orange and yellow and white. And I pulled the harness down right here where it's been exposed. This clip was broken off and this had been taped up, so I thought I'd pull it apart here and find these two wires and pull on them, just tug on them to see if there's any opens in the wires. I'll set this up if I can. So I'm pulling on the yellow wire now, and you can see that it's intact. And I'm pulling on the black wire, and you can see that it's connected. So there's nothing wrong with those wires, at least up to that point, and I tugged on them going up to the fuel pump and they seem fine. So we're going to tape this back up, reconnect it, and order up a fuel pump, and then drop the tank and check it.